In lesson 7.1, questions 1 and 2, you're going to be using rectangles to approximate the area under different curves. So I'm going to show you what the case for n equals 4 looks like for question number 1. The function in question number 1 is f of x equals x. The left-hand part of the interval is 0, the right-hand part of the interval is 1, and the number of subintervals is 4. So when I cut the interval from 0 to 1 up into 4 pieces, I go from 0 to 0.25, 0.25 to 0.5, 0.5 to 0.75, and 0.75 to 1. Notice the width of each rectangle is 0.25. We're going to call that delta x. The height represents a sample from the value. So let me show you what I mean. Where my arrow is, this is 0.25. If I follow up, this is f of 0.25. Since the function is f of x equals x, then when I plug in 0.25, I get 0.25. So 0.25 is the height. Width times height is the area of the first rectangle. The second rectangle, the width is 0.25. The value on the x-axis here is 0.5, and when I plug that into the function, I get 0.5, so that's the height. So 0.25 times 0.5 is the area of the second rectangle. The next rectangle, the width remains the same. The value here is 0.75, and when I plug in 0.75 into the function, I get 0.75. Width times height gives me the area of the third rectangle. Lastly, the width is still 0.25. Plug 1 into the function, I get 1. So 0.25 times 1 gives me the area of the last rectangle. A sub 4, which would be the area of 4 rectangles, will be whatever I get when I add up those 4 areas. And so that's how you do it for 4 cases. So now, if you understood this lesson, you can now do it for n equals any case. God bless you, wherever you are today.